Hi, good morning. So I already had a few talks about security and Java in general in the last couple of years. So this year we are going to focus on digital signature and Java cryptography.
So I would say, let's meet. Werner, who are you?
Yeah, I'm the current Jakarta EE Specification Committee representative for committers. I was for about 9 years in the JCP Executive Committee, and I'm also maintenance lead of the units of measurement GSR, of the money GSR, and maintainer of a lot of other mostly Java-related open source projects.
Hi, good morning from my side as well. Thodoris Bais is my name, or Thodoris Bais in English. I work as a Scrum Master at ABN AMRO Bank, a bank in the Netherlands. I'm also founder and leader of the Utrecht Java user group. And besides, I'm also helping people find their own motivation via my own company, Agile Leaders. However, we're not here today to talk about ourselves. So we're going to talk about digital signatures, as Werner correctly pointed out. And here is a very short overview of the agenda for this morning. So, in short, we're going to talk about eHealth and eGovernment signatures and certificates. We're going to focus a bit on the DSS framework itself. And then we're going to talk a bit about insecurity, concluding with a demo. Of course, we'll try to also make some time for Q&A by the end of the session. So nowadays, we are actually approaching 2020, right? So there are quite a few things to take care of regarding technology. Yesterday, we even had the technology awards, right? So let me actually start with a very short intro on eGovernment in Germany, where Werner lives and works, and in the Netherlands, of course, where I live and work. First of all, what's the current status of eGovernment in Germany? Actually, Germany is opening up and trying to adopt more and more eGovernment in the public sector through information technology and communication. You can distinguish two sectors, actually, internal and external. And of course, regarding internal eGovernment, we are mainly using IT in the public sector without any contact with the citizen. So, for example, that could be medical records, exchange between public authorities, and of course, healthcare providers and pharmacies, etc., etc. Now, what happens in the second part? What happens in the external part of this e-government appliance in Germany? Of course, there we have websites for services for citizens, patients, customers, companies, and so on and so forth. That was a very short overview of the current status of eGov in Germany. What about eHealth, though? So, there are mainly three things about eHealth. However, it is worth mentioning, first of all, that Germany is still at an early stage of application in eHealth and mHealth, which stands for mobile health. There are, however, some advantages and possibilities to see how both are used and can be used soon. For example, as you see in the very first one, it can be used for long-distance communication, for example, or even especially in rural areas or where there is any kind of shortage of doctors, of course. In the second picture, or in the middle one, you see actually some health data via computer-based procedures for the collection and transmission and evaluation of health data. And of course, we couldn't really skip mentioning the monitoring of patients, for example, the chronically ill ones or voluntarily self-monitoring ones. I can still recall Werner giving a talk last June, I think, in Utrecht about the quantified self. So, that was more or less a short overview of the current situation of eGov and eHealth in Germany. What about the Netherlands, where I live and work? So, in the Netherlands, as you can see, we have DigiD, it's DigiD, as you can see it, which is more or less taking care of any kind of connection you need to do for your eHealth needs. And more specifically, that happened after the regulation of the European Union about the eIDAS, which is about accessing Dutch, or at least we had to do it for accessing Dutch government services online. Now, what did this legislation mean for the Netherlands? Of course, we had to create a service itself where any kind of patient, either if we're talking about a patient having a Dutch nationality or someone else who comes from a different country, like myself, for example, because I'm Greek and I relocated to the Netherlands. What happens if I wanted to check my current status of health? So this is what DigiD provides us with. We can use it to actually do quite a few checkups or things online. And first of all, SVB. I'm gonna walk you really quickly through this. SVB is something like you can check the current status of the social health insurance. And of course, second one, you can submit your tax return to the Tax and Customs Administration. Third example, you can check your pension statements to your pension provider. And something that is really becoming more and more of a hype nowadays in the Netherlands, you can also object to the assessment of the value of your property under the valuation of immovable property. That was a bit about eGovernment. What about eHealth? There are also three main things to keep here in mind. First of all, I need to point out that Netherlands or the Dutch government is encouraging the healthcare sector to expand telehealth services. And of course, that actually means that we need to take care of access to medical records. Nowadays, or at least the goal of the government for 2019 was to provide at least 80% of the chronically ill people with access to their own medical records. Second of all, we need to talk a bit about health monitoring as well, right? So once again, the goal of the government until or by 2019 was to actually provide the 75% of chronically ill people and vulnerably elderly people with some services so that they should be able to monitor certain aspects of their own health status. Of course, in the meantime, we also need to take care of some online conduct with care providers. So people receiving care and support at home should be able to communicate with a care provider 24/7. Now, how could we really achieve those goals in the Netherlands? First of all, Zorg voor Innoveren. It is a Dutch website where startup founders on the health field can really connect with each other and share information, and they're also getting some help from the government to make their next step towards eHealth. Second of all, of course, we need to talk about making digital data sharing easier. The government is trying to make people come together. Third of all, sharing eHealth know-how. The government tried to make people from these different fields come together. So patients, lawyers, and of course, doctors. And one of the last ones, I would say, we also need to have some personal digital healthcare environment, right? For example, a personal health record where the patient is able to check his current health status 24/7. I'll touch a bit upon the benefits of eHealth. First of all, it's quite time-saving, right? You don't really need to go to the doctor and ask them for all your history about your health status. Everything should and will be online. Second of all, we're talking about an insight into our own health, where a personal digital healthcare environment gives people more insight into their health. And third one, and most important one, I would say, what was the main issue of the past? That whenever you went to the doctor, they were like, oh yeah, I need to check all this history in my closet. You know what? That's done. That's not going to happen anymore with the appliance of eHealth. So, a bit about the requirements for secure transmission, given that we are talking about a new era, given that we are talking about migrating to an eHealth world. First of all, we need to talk about integrity of data, right? So when we are talking about integrity of data, we are talking about messages that should not be able to be falsified unnoticed. Second of all, identity. A message should not be clearly assigned to the sender. Third of all, authenticity, of course, where the identity of the sender should be verifiable. And what is the most important one here? Confidentiality, right? So messages should not be read by unauthorized persons. And we're gonna show you a few demos later on with what I just mentioned. Keep those 4 things in mind. So there is some need in the meantime to also touch a bit upon authenticity of author and data. Of course, there is some assignment of data from the author to the signer, where we need some protection against denial by signatory. In the meantime, of course, we are talking about protection of data against manipulation, which could be manipulation on the transmission path or through the receiver, of course. So I'm wondering, what are the risks, actually? What risks could e-communication entail? For example, I might be wondering, who is my counterpart? Or who is reading what I'm sending? Or has anyone changed something even? So there are some solutions. What are those solutions? E-signature and encryption. When we're talking about e-signature and encryption, we're definitely talking about unauthorized third parties being not able to read an encrypted message. And we're gonna see it later on in the slides, of course, where the solution is to provide electronic signatures. Sorry. So, how are those electronic signatures? How do they work? How do those electronic signatures work? Let's talk a bit about the functionality of them. And what do we see in the picture? We see, of course, some lockers, right? So when we are talking about the functionality of digital signatures, we're talking about an electronic signature, which is a cryptographic method that uses 2 asymmetric keys. A private key, to be kept secret, of course, and to be used to encrypt the hash value of the document, and a public key, of course, which cannot be used for decryption and should match only one private key. Here is a very basic schematic on the way a signature process flow works, or should work, at least. So what do we have? We have the signer here, which who has some data to encrypt, or who needs to sign some data. The signer is using a hash algorithm, and via the hash algorithm, you're gonna get a hash value of the document. On top of that, you're using the public key. And remember what we just mentioned? A public key matches only one private key. So, given the encryption that will happen after applying the public key on top of the hash, you have a digitally signed document, right? So, I have my document, I have my hash algorithm, I create the hash out of the document, and I sign it using my private key. So I already have my digitally signed document. How could someone else, Werner, for example, take my document and verify that it's the right one? Now we're going through the network transmission where Werner gets my own document, which is digitally signed. Now, using a hash algorithm and a public key, Werner creates two hashes which should actually match. That is the moment that you can say, okay, that's indeed the right document I should have. And in case there are any questions, we're gonna show this more in action during our demo. However, now, what happens with the signature process itself, Werner?
Yeah, so here's a slightly more detailed flow diagram of the whole signature process. There are various different signature types. A simple electronic signature, that's what you would also use, for example, in pretty good privacy to sign your own emails. An advanced electronic signature, or ADES, or a qualified electronic signature, which can also be additionally hardened with a provider accreditation by a trusted provider. So here you see the level of security. The advanced electronic signature has an owner that can be uniquely identified and is assigned to exactly one signature. The signature has to be generated by means of sole control by the owner. So in many cases, this is also done via two-factor authentication, for example, nowadays, especially with PSD2 in banking. Most of the banks are now requesting the bank owners to, for example, use an app.
Definitely.
So that would be a way to sign by having it under sole control with two factors. And the signature must be able to recognize if something in the signed document has changed after it was signed, and in this case it has to be invalidated. An advanced digital signature can not only be held by an individual, it can also be held by a company or a service or an app. If you go a little further, then you have the qualified electronic signature, or QES, which has to have several attributes. Usually the owner has to be a natural person in this case. And the signature can also be restricted, that it's only valid, for example, for a quarter or a day. And there can also be usage restrictions. This is often applied, for example, when you have a certain country or other areas that the signature only applies to a particular purpose. There are trust centers. We'll actually see in the live demo. There are also some here in Bulgaria. The web app shows a list of trust centers for each country. And the trust center has to undergo a lot of vetting to make sure that, for example, they cannot be hacked or the signature creation process can be altered in some way. And they also have to be tested and certified regularly. A digital certificate is a document that links a public signature to the name of the holder, which can either be a natural person or a legal person, like a company. Now let's look at some of the signature formats in the advanced signature digital electronic signature format. So you see the ADES in all those acronyms. First of all, CAdES, almost sounds like a Greek god, like Hades, but that's for the XML documents. CAdES is the more general purpose underlying binary equivalent. You can sign all kinds of documents or files, for example, images, Word documents. PDES is a bit of a specialty that sits on top of CAdES, and it allows to also take certain properties of a PDF document into consideration. Otherwise, it sits on top of CAdES and can do everything that CAdES can do. And there's also a so-called associated signature containers, or ASiC, which actually can apply to each of these. So they are a bit of a cross-cut. Signatures can be packaged in various different ways. First of all, enveloped means that the signature is embedded in the document itself. Enveloping is the reverse. So you get the signature, and the document is embedded into that signature. Detached means the original document is not even changed, but the signature is created separately, and then they have to be verified together. And internally detached is a special form, especially in Germany, in eHealth, for emergency medical data. This is, for example, the way that these are packaged. But most of those are not compatible across different countries.
Yeah.
Only in an ideal world.
Indeed.
So let's look again in more detail about how the hash is transferred and verified. We're going to see that in a bit. Here are some of the possible statuses of the signature validation. So the high-level result can either be everything passed, everything failed, or something in between which is indeterminate. That means something may be okay, but not everything. And especially a little caveat, all those signatures that we are going to create, because they are self-signed with a test dummy certificate, you will usually see indeterminate results simply because the signature is created with a test certificate that is not in a trusted chain. In the EU, of course, in an ideal world, document creation should work across countries, ideally even outside the EU, and it does, but in most cases where this really works is certain eGovernment areas. Thodoris also mentioned that in a few cases, certain documents and digital IDs from Germany are accepted in the Netherlands. I'm not entirely sure. I think the other way around, it's probably a little harder, or they're still working on it.
Definitely harder.
There are also examples of exchanging legal documents. For example, Germany and Poland, until it was stopped a little while ago because they ran out of money. They had a very successful cross-border exchange trying to catch car thieves. So German police officers would even go to Poland and together in a joint task force with their Polish colleagues would arrest car thieves that were stealing cars and transferring them to Poland. So that was an example where the jurisdiction and the legal and the police forces actually also exchange information, and obviously they also have to be signed and not tampered with. But in the healthcare sector, it's probably the most difficult place where I know, because I'm currently helping a German provider to boost up the eHealth a little bit, and there it's even quite tricky that the different vendors or the different insurance companies get onto a common understanding of certain formats, so that fields that exist for one insurance company don't lack in another one.
Yeah.
So let's look at the DSS framework. This is actually from the station just one stop between here and the hotel, which is conveniently named European Union. The DSS framework is created with funds and support by the European Union. So there's actually some benefit, and not just trying to regulate how big the banana should be. So the DSS framework is an open source library written in Java. It supports the creation and verification of interoperable electronic signatures. And the three main use cases, except for the creation of certificates, we will show creating a signature. I think for the lack of time, we won't show extending an existing signature, but that is also possible, where you can amend details to an existing signature, but we will show the validation of a digital signature. The DSS framework covers all of the eIDAS standard that Thodoris also mentioned. In healthcare, this is mandated everywhere, and also in other places, for example, with PSD2 and banking, those digital signatures apply exactly the same underlying regulations. It supports all the various formats, all the different forms of signatures like CAdES, XAdES, PDFBox, and the various types of containers. And it also allows certain profiles where you can define how detailed you actually want the verification to happen. Now a little bit about PDF spoofing. There's an institute of the Bochum University, not that far from where I'm based. It's part of, I know some of our Dutch Jakarta EE contributors said they are literally across the border, so Bochum is
Indeed
actually not far from the Netherlands, and they have specialized in the security of digital signatures, especially those in PDF, and they actually came across some fascinating cases where they could spoof a PDF from Amazon saying that you're eligible to receive a refund of $1 trillion. I guess maybe for a country like Bulgaria, that might actually be enough to reduce the entire national debt. In America, it would only be about 1/5, I think, but it will also be significant. But yeah, we're going to show one of those altered PDFs, and also that the DSS framework and the underlying security mechanisms are able to catch that and not say that it's valid. Okay, so now to the demo.
Now to the demo, through the demo. Let's see. So we talked about PDF insecurity, digital signatures, and digital signature formats. Let's see what I'm gonna show you now. So first of all, let me get out of here. What are we gonna do? We're gonna try to digitally sign a document. And given the three different formats Werner already mentioned, yeah, I'll do it. I'm gonna start with a sample XML file. So let me show you the file itself. I just have a very basic books.xml file somewhere here, right? Can you see it? Yeah, is it visible? Cool. So you see, nothing super special is in here. So I'm gonna take this one and I'm gonna sign it digitally. Given that I know nothing about digital signatures, what am I gonna do? How am I gonna digitally sign it? Shall I use my own application? No, there's already one solution from the DSS framework itself that Werner has already mentioned. So I'm gonna quickly show you the application itself. This is a very simple application. I'm not gonna dive into the details, we're going to share the links later on. For now, this is just a Java FX application which is able to sign documents in a digital way. So I'm expecting a window like this to come up. And what did we see? What do we see here? Of course, there are a few fields. The file to sign, container type, Werner mentioned it, also signature format, level, digest algorithm. Remember what we said about the entire workflow of signing a document digitally, and of course, the signature token. Let's go through them one by one by first of all selecting a file. I just have a very sample box XML file, right? So I'm gonna select this one. Container type, let's leave it as none for now. Signature format, what should I use? XAdES, let's say. And I just want an enveloped packaging, right? With a level of baseline B, which is the very basic level of signature.
You can also show it to do it both enveloped and enveloping, because then you see the difference in the structure.
Yes, we'll do that as well. So regarding the digest algorithm, I'm going to use SHA-256. And now, remember what Werner mentioned about the three different formats, the three different signature tokens, the three different results of digital signatures. You can have total pass, total fail, and indeterminate. Where does indeterminate where does indeterminate comes from? It comes from a certificate which comes from an untrusted authority. Untrusted authority, I will show you. As a keystore file, I will just use a very sample keystore file I created for this demonstration using my own value chain. Of course, I should have a password here if everything goes fine. And if you saw it in the background, something happened. So,
can you save it on a stick?
Yes, I will do it directly to the stick as well. Why do we have a stick is the question. Because Werner supposedly lives in a different country, and I just met him for 5 minutes. So he needs to verify the document I will sign right now. So I'm signing a document using this application. And of course, it's unable to save the file. So I will save it here on my own machine as the very first. Let me check. Let's go again to the keystore file itself. So I'm giving the password itself, and let me try saving it first on my desktop. Let's see. So I saved it on my desktop, and how could I see this now? So that should be it. So this is the enveloping part. Again, the very first part is exactly the same as what we saw earlier. However, on top of that, we also see, let me just zoom in here, we just see the signature itself. Of course, do not pay that much attention to the signature itself, because it contains some hash values and so on and so forth, but this is the enveloping signature. Now, I'll keep that one on my desktop, and I will try creating an enveloped one as well, so that enveloping one, so that we can move both of them to Werner's stick. So, what am I gonna do now? We do have our keystore file, and we have everything else here. So, I'm gonna go for an enveloping one. I'm gonna give my password as well, and I'm gonna sign that. And let me just sign it as, save it as enveloping. Yes, of course, I had some other files there. So, let me just try opening this as well. Should be somewhere here. Wait, let me get it in a different way. That's it. as Werner mentioned, here you get the signature, and then about the document, where do you get the document, right? So the document, you should be able to find it somehow else. Maybe you need to transfer it also via the USB stick, right?
No, it's actually encoded in this case. So the document is hashed and encoded.
So as you can see, it should start from somewhere here. So for now, what did we have? We signed two documents, two sample XML documents, using an enveloping signature and an enveloped signature. Shall we transfer those two files to Werner's computer to check?
Okay. Do you also want to do a CAdES or?
Actually, do we have time for a CAdES as well? We can do a CAdES as well. Let me just do a CAdES.
Create the image.
Yes. So as a CAdES, we're just gonna try to find a different document, which could be something like a brain tumor image, right? So let me try finding one sample that I have here, and I can show you this image here.
It's not a sad coincidence that the Roxette lead singer died of a brain tumor last night, but
yes, but at least let me show it for this particular demo. Again, I'm gonna use my Untrusted Authority certificate. So, and I'm gonna sign it. Wait, I'm not getting it. Yes, I need to do it all over again. Maybe something needs to happen. Oh yes, sorry.
Yeah, enveloping.
Sorry. Indeed. So there it should be.
So as you see, the app also automatically recognizes, and for certain types, for example, CAdES and PDES are usually binary structures, so you don't really have a readable document unless you use a viewer for that. So there are certain types of signature packaging that do not make sense for them.
Indeed. In the meantime, what did I do? I just closed the application, and I'm going to transfer the signed documents to Werner's machine or to Werner's stick as well. So let me just create a new folder here. Am I allowed to do this? Apparently not. Let me just try transferring this one. Oh. Apparently I'm not. So let me do it once again. 2, 3, and then my books.xml. Copy. Oh, maybe. Yes, maybe it's a read-only one.
Or is it a format that doesn't work on Mac?
No, apparently not.
Oh.
But anyway,
try the store. I think we have internet. Do you have internet?
You know what? I'm gonna just get my own internet here. So it doesn't matter. These are the demos of a live demo. What am I gonna do now? I'm gonna use the web application to validate the signature I just created, because DSS Framework itself provides a web demo so that you can either validate the signature or digitally sign a document itself. So let me see. I should be connected to my own.
That means you can try it all by yourself without having to run it?
Yes.
Well,
so just give me 1 second.
There is Wi-Fi, by the way. The NDK free. Can you see that?
No. Which one?
NDK free.
NDK free. Where do you see that? No, I cannot. Wait, let me just refresh this one. Where?
NDK free Wi-Fi, the one without the lock.
Oh, free?
Free, yes.
That's cool. So hopefully it will work. Let's see. Yes, and thanks a lot. So what am I going to do? The signed file, right? What did I have here? First of all, I had the books signed XAdES baseline B. And the original file is, of course, nothing else than my books.xml file. And let me just submit and see what's going to happen. Let's see. Waiting time. Yes. So what do we see here? Of course, a detailed analysis and detailed result with an indication of indeterminate. And why is that? Because remember what Werner mentioned? He said most of the documents we're going to sign today are going to be of an indeterminate format. And why is that? Because the P12 certificate I used to digitally sign my document was created by myself using my own machine. And of course, the application, the web application itself is not able to verify or to even trust my own certificate. That's why we see a result of indeterminate. And as you can see, the certificate chain itself is my private certificate, which I used for the purpose of this presentation. Now, of course, you also have 2 or 3 different tabs to validate it yourself, to check for yourself. It provides a really, really good overview on how things should be. Do we have more time for one more demo?
Maybe we can try to switch over because I'm running the same application locally, and that allows us to also show how many of you are using REST or SOAP web services. Okay, then maybe we should show the REST way of accessing it.
Yes, let's go for that. Everything on the fly today. First session, so that you wake up.
Okay, there we go. So now you see the same application that I started running in a local Tomcat. I also mentioned the list of trusted providers. So let's just briefly have a look. These are all the trusted providers here in Bulgaria that allow you to use a QAS signature if you want the highest level of advanced digital signature. So I will just use 2 more PDFs. First of all, this is a QAS signature. So this is probably one of the only example files where you would see that everything has passed, because this is a qualified digital signature and the chain of trust is legitimate, so it's based on one of those trusted providers. So this is why this one has a total passed, while everything that has been self-signed is indeterminate because there is no chain of trust. And let's also try the Amazon.
You also have a different one about eHealth.
So yeah, in this case, that's the Amazon refund, where the latest version of the Amazon, the Adobe Reader also shows that the signature is invalid, and we get the same result here, that there's no valid signature. In fact, in this case, I think the signature itself is not even recognizable, but it doesn't tell you that it's a valid signature by Amazon. And then last but not least, there's a Postman project also in the DSS framework with some ready-made calls. So first of all, let's show some of the keys. Here in REST. There's also a list of certificates. And last but not least, let's do a validation. Extend. Validate signature. There we go. So this has a prepared REST call for actually a detached XAdES signature, and you can also see that the result is valid. But here you actually see a similar result to the web framework where it's provided in XML, but here it's all transferred into JSON, so the usual REST clients are happy to use it.
Shall we change?
No, I think we have it here. So there are links where you can find the project. Probably the best entry is to just go to GitHub to ASiC DSS. And here are a few other sources of underlying technologies that would exceed at least the 1 hour talk, but it's using a lot of common technologies like Bouncy Castle, Apache projects like PDFBox, or Apache Sanctuario for the XML digital signature handling.
Cool.
Okay. Not sure if
I'm gonna
there's any.
I'm gonna change for the last slide. Thanks a lot for being here today with us. You can find us on Twitter. Werner Keil is Werner's Twitter handle. Thodoris Bais, my Twitter handle. And of course, if you're still around up until today, we yesterday faced a few difficulties with transportation and so on and so forth. I'm giving, by the end of this day, a motivational talk about career, how to grow your career at 5:20 at Hall 7, if I'm not mistaken. Please check out the agenda on the website. And once again, thanks a lot for being here today.